Today we'll have a virtual class, of course, as everybody knows. Um, let's continue for what did we say before. We have already started with the motion topic, if you remember. So that motion, as you remember, that starts with the speed, right? And then we explain what the difference between speed and velocity. And also we said that how can we identify the speed and how can we identify the velocity? That's why we have stopped at the beginning of the acceleration and we explain the meaning only of the acceleration. So whenever we start to that point, we just look at the examples of the acceleration. How can we say that an object accelerates? Whenever we are sitting outside our cars, we will find out that the cars contains a counter in front of the driver. This counters in kilometers per hour. It means that this is the value on the dimensions of the acceleration measurements. So whenever we look at that topic, we'll find out that the explanation of the velocity saying that change in velocity means the acceleration, that the object change its velocity. That's why we're supposed to have a graph. This graph will describe exactly the relationship between the distance, which is represented by the y-axis, the vertical one, and the horizontal one, which represent the time in seconds. So whenever we have this relation, we would like to see exactly that each time you take a step, you are changing the velocity of your body. So you are probably most familiar with the velocity changes of a moving bus or car. So whenever we have this relation, let's just refer at the beginning to what we can representing here. This is the x-axis which represents the time in seconds. If we have already measured the time from 0 up to 1, it means it represents 1 seconds. So we can exactly refer to the point which above that 1 seconds here, which exactly equal approximately, we can say 2.5 or 2 meters only, because the distance here represented by the vertical axis, which represents the y-axis, while the x-axis represents the time values in seconds. Now, if we continue and found out that the time is still extended up to reach up to, for example, 4 seconds. Exactly at 4 seconds here, we can look vertically, we'll find out that the time, the distance traveled by the objects or by you or by your car, approximately 80 kilometers, right? Or 80 meters. It refers here as meter. I'm sorry if I said kilometers. So from this value, we can find out that there is what we call, if you still remember this relationship, which we named as before as a directly proportional, as D means the distance, stands for distance, will be directly proportional to the time, which is represented by the t in seconds. So the rate at which velocity changes occur is called the acceleration. So what is the acceleration? A change of velocity per time. It's exactly as we will find it here. How can we measure the acceleration? The acceleration means the final velocity at the end, minus or negative starting velocity means that the initial velocity divided by the time. That's what exactly called change in velocity per the time. That's to contain the problems, which has already that two values. When did you start your velocity, change your velocity, and when exactly did you finish? So the acceleration again could be measured in this value. Final velocity minus starting velocity or initial velocity per time. That's exactly the results, which refers to the unit meter per seconds, means the acceleration. After that, whenever we look at the graph and we need to exactly calculate the velocity according to the relationship which we have already mentioned before, we'll find out that the acceleration or the velocity has a direction. This direction, which making as a vector value, the direction according to the coordinates. If you remembered, this is a y-axis and this is a exactly x-axis. Whenever we look at that one, we'll find out that the y-axis for us here representing the vertical and the x-axis here represented the horizontal one. If the direction of the acceleration from left to right, as we see here, we'll find out that it represents a positive direction. While if the acceleration starts from up to down vertically, like falling free or free fall from the sky to the bottom of the gravity down, we'll find out that it represents the positive acceleration too. Of course, vice versa. If we said that horizontally from right to left, it represents a negative acceleration, as here. And if we said that from bottom to up, from the bottom to up, it means from down to up, it represents exactly the uh, positive, positive acceleration. But in this case, we'll find out that the value which represents exactly delta x, or a change in the distance, if we said delta x, it means that the object moves horizontally. But if we said delta y or dy, it means that represents exactly as the vertically. It means that here downwards or upwards. It depends on the value of the problem which you have it and the direction of the object which moves. So we'll find out that in science the acceleration refers to increasing the speed, decreasing speed, or changing direction. Also, increasing speed means an object speed increases, changing with the time, and the object accelerates. So, for example, if we said the bike accelerates when it costs, means just like it tracks down with the gravity down a hill. Whenever you have a bike and going around the road, will find out that you are pushing more than the normal velocity which you have. It means your body and your bike accelerates. Also, whenever we look at the value which you have it here in the opposite sides, decreasing speed means deceleration or negative acceleration, as exactly what we said. From right to left, it means that negative acceleration, right? And also from down to up, it means, or from bottom to top, it means negative acceleration. That's why whenever you are riding a car and this car come closer to the traffic lights and you find out the red lights heads up, you'll find out that the car, or you need to stop your car at the red light traffic. That's why you are using your brake. Whenever you reach up to this limit, you'll find out that the final velocity for you, it's approximately zero whenever the car stops. While the beginning or the initial velocity, it means higher. That's why whenever you have the change in velocity, you'll find out that the ratio must be here in negative charge or a negative signs. Also changing the direction, and I explained that before for the acceleration. It's a kind of acceleration. Whenever the object change its direction with the time, it means that you accelerate or the object accelerates. So objects can be accelerating when they're traveling at a constant speed. Even if it was moving in a constant speed, it means accelerates too if they are changing their direction or moving in a circle. The seats on a Ferris wheel, everyone knows, if you visited London before, you'll find out that the Ferris wheel accelerates because they have already the movement of a circle, or they are moving in a circle. So if we look at the example which you have it, we can brainstorming together, find out that the question says, which of these describes the object with the largest acceleration? Which one of them, whether an object with a small change in a velocity over a small change in time, think with me and try to answer after we finish, or an object with a small change in velocity over a large change in time, or an object with a large change in velocity over a small change in time, or lastly, an object with a large change in velocity over a large change in time. I'll give you just 30 seconds, I'm sorry, to think about it. I think, yeah, I can see someone find the answer. So the answer is the last one. Why the last one here? Because whenever we can say that an object with a large change means that the difference of the change in velocity, v final negative v initial in a large value, divided by the large change in time, of course, it means that this one wrong, right or not? Wrong. So we are wrong. So the correct one will be the Third one, yes, the third one. You are great. An object with a large change in velocity over small change in time, it will give you the greatest value of the acceleration. So the third states it is the proper one. So brainstorming or your feedback more than important as a good reflection for everyone. So by this way we can reach up to the last moment for us here, which refers to say that the speed as only magnitude means scalar value or measurements, while the other one, the magnitude and direction together, as we represented before during our explanation during the previous days, that the vector amounts or vector relationship always with the objects or the things which they have a magnitude and direction as well. That's why the example of the vector could be velocity or acceleration, while the example of the scalar objects means speed. I hope that everyone understood, and I think that the next step for us that to feed me back about your understanding, and we'll meet together during the Socrative practice. And I hope that everyone enjoying. And again, I'd like to apologize if I make you busy during your off. But remember, it's not our off. It just like come as a situation for everyone. But I know they are great students, and I hope the best for everyone. Have a nice time, and just like stay with me just for a few minutes or maybe half an hour to practice together about the Socrative competition, and we'll see that who is able to answer. Don't forget that this one give me at the end a resultant. This one reflects exactly the best students and the middle students and the weakest students. And I think that I don't have weak students, I don't have middle students, but I do have a very good students, excellent and great students, and I know all of you are great and waiting for your meeting. Just download the Socrative and just make an account and copy my code, which I'm going to deliver to everyone. Whenever you insert your code, you'll find out that you are inside our class. And I hope that everyone enjoying, and let's have fun for a few minutes. Thank you very much.